Alright everyone, welcome to another day of mathematics. So let's go ahead and get started. In today's lesson, we are going to be talking about solving linear systems by graphing. But before we even start graphing them, we kind of have to know what a system of equations looks like, okay? And a system of equations, in this case a linear equation, is going to be a combination of lines kind of put together. So for example, a system could look like this: 3x plus 5y equals 7. And negative 2x plus 4y equals 9. These two would be the system. Ooh. Alright. It provides us with lines. As you get into higher levels, it might not be lines, but today, since we're talking about linear, aka a line, our graphs are going to look like lines. Alright. Before we get into the heart of systems of equation and graphing them, we kind of need to know, how do you check if a point, one point, is a solution or not? So in example 1, it says check whether the following are a solution of the following system. Okay, so here's the first point, 1 comma 4 they gave us, and they give us a solution, and the solution, the system is right here. Okay, I'm highlighting it right now. And what we want to know is the point that they gave us, is that a solution to the system? Well, we know that x is 1 and y is 4. So what I'm going to do is take each one of these, x minus 3y equals negative 5, and check to see if 1 comma 4 makes sense, meaning do I get a true statement? I'm going to substitute in 1 for x minus 3, y is 4, and I'm going to hope that it equals negative 5. So we have 1 minus 12 equals negative 5. Well, 1 minus 12 is negative 11 equals negative 5. Notice that I did not mix the two sides. I just kept things on their side and simplified. And then I get this. Now, hopefully you're going, Mrs. Pagan, that doesn't make sense. Okay, yeah, you're right. Negative 11 does not equal negative 5. Therefore, we can say, I'm going to do, in calculus we kind of go into therefore. That's what that means. 1 comma 4 is not a solution. Now, some of you might be going, well, what if it worked for the other one? It doesn't matter if it works for this one or not. Because it failed one, it fails the entire system. Okay, so it has to be good for both of them in order for the system to have that as a solution, have that point as a solution. Alright, let's look at example B. I'm going to draw a line here so I don't get confused. Well, x is negative 5 and y is 0. Okay, so we're going to go ahead and use, I'm going to start with the first one again. We have x minus 3y equals negative 5. That's the first equation that I see right here. So I'm going to input negative 5. I like to put parentheses because sometimes I make silly mistakes. Times 0 equals negative 5. Well, anything times 0 cancels out, so we're left with negative 5 equals negative 5. Yeah, that does equal. That's awesome. Okay, so we know that's a true statement. That's good. Now, we can't just say that this point, negative 5, 0, is a solution at this point. What we need to do is check for the second one. So I'm going to go ahead and test the second one. And I'll draw a little line. Negative 2x plus 3y equals 10. All I did was rewrite this. Now I'm going to input my values. Negative 2, negative 5 is the x, plus 3 times 0 equals 10. Well, 3 times 0 is 0. I don't even calculate it. Negative 2 times negative 5 is 10, and 10 equals 10. Yeah, that's true as well. So since both of these are true, so this is true, and this is true, that means the following. Therefore, negative 5 comma 0 is a solution to the system. And not just any system, but the system that they gave us. That's awesome. Alright. Now that we know how to check our work, let's kind of talk about how do you solve these types of problems using graphing. Well, let's kind of look at example number 2. It says solve the system. And what you're going to see is here's our system. Okay? And we have two equations. Here's the first one. Here's the second one. I like to label them sometimes because I'm old, you know. I forget things. Now, this one, I see it as y equals 1x plus 4. And I like to write the 1 just to remind myself that the slope is 1. And the second one, I see it as y equals negative 1x plus 2. All right, let's start with the first one. I'm going to go ahead and graph this in green. Alright, let's go up to 4 and use our slope. Out 1 over 1, out 1 over 1, out 1 over 1. And I just keep going. And I go the other way as well, just because I like to have exact locations. Keep going, and then I sketch my line. There it is. Alright. Then the second one I'm going to go ahead and graph in blue. I start at 2 at the y-intercept and use the slope negative 1 over 1. Down 1 to the right 1. Down 1 to the right 1. To the right 1. To the right 1. And keep going the other way as well. Woohoo! Okay. And now I'm going to go ahead and sketch my graph. Alright. So, where are the answers? Well, the answers are where the two lines meet. And if we look carefully, it meets at that red location. Stop going over it. Ah! Okay. So it means right there where I'm trying to make a red dot, but it keeps disappearing on me. And therefore, that is our final answer. Now, a lot of people will leave it like that, but you can't assume that people know where that's located. So we're going to go ahead and find out. Negative 1 over and up 3. So the solution is negative 1 comma 3 is the solution. If you wanted to be sure, what you can do is what we did above to check your answer. Put negative 1 in for x and put 3 in for y. For both of these to see if it is a solution. That's why we taught you how to do this example so that you know how to check your work. Alright, let's go on to example 3. Now, example 3 is a little bit more intense. No reason other than example 2 gave us y equals. So it gave us the lines in slope-intercept form. This one, however, is in standard form. So first thing we want to do is take 3x minus 2y equals 6, which is this one right here, and put it into y equals format. So I'm going to go ahead and subtract 3x, nothing we haven't done before, negative 2y, this cancels, equals negative 3x plus 6, divide by negative 2 on all the pieces of the equation. We get y equals 3 over 2x minus 3. This is now our new equation. So we've changed the first equation. Now it's in this format. So we can actually jump in and graph it. I'm going to start at negative 3. Here's my point. Use my slope, which is 3 over 2. So up 3. 1, 2, 3, right 2. Up 3, right 2. Right, up 3, right 2. Up 3, right 2. I'm going to go the other way. Down 3, left 2. Down 3, left 2. And here is the graph. Alright, we got our first line. Now we have to do the same thing for the second one. So I'm going to actually just myself draw a line because I don't want to get confused in my work. I'm going to rewrite. This is the second equation. We're going to do everything in green now. 6x minus 4y equals 12. Get it into y format by subtracting 6x on both sides. We get negative 4y. This cancels. I always forget to cancel that first. Negative 6x plus 12. Then divide by negative 4, negative 4, negative 4, and y equals, this negatives become positive. 6 over 4 simplifies to 3 over 2x minus 3. So that's just odd because I feel like I've seen this before. Has anyone seen it before? Great job. Yeah, you can actually see that it is the same equation as the first equation we graphed. So we're going to go to negative 3 and we're going to go up 3 and over 2, up 3 and over 2, and it ends up being all of these points again. So what does that mean solution wise? Well, solutions are where the points touch. Since all points touch, the other line, the solution we get, I'm about to put it in this little bubble, is infinitely many solutions. Since the line keeps on going, I couldn't tell you how many solutions there are. There are just a lot. So we say infinitely many solutions. All right. So let's go into the last example we're going to talk about here before I let you go, and then we'll discuss some of these concepts in class. But we have the same problem here in example number 4. So you can see that they're not in slope-intercept form like we want them to. So the first one, I'm going to go ahead and solve it in black. So I'm going to put this to the side. I don't have that much space, so I'm just going to write it right here. Subtract 3x on both sides. We get negative 2y equals negative 3x plus 6. Divide by negative 2. And we get y equals, that cancels, 3 over 2x minus 3. That's weird. I feel like I've seen this before. So that's the first equation. So we're going to go to negative 3 and use our slope. Up 3 over 2 to the right. 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 Down 3 over 2 to the right. Down 3 over 2 to the right. And here is our line. All right. So we still have to get the second one done. So I'm going to do the second one in blue. Oh, I'm sorry. I didn't mean to cover the equation there. Let's redo that. There we go. And because I don't have space over here, I'm going to move it to this side just because I don't want it to look too crammed. So here's 3x minus 2y equals 2. I'm going to subtract 3x. Negative 2y equals negative 3x plus 2. Divide by negative 2. Divide by negative 2 on everything. Y equals 3 over 2x minus 1. All right. So we're going to graph this one. This is our second one, right? We're going to start at negative 1 and go up 3. 1, 2, 3, and over 2. Up 3 and over 2. Up 3 and over 2. All right, well, let's see. And what we're going to notice is, wait a minute, they are not touching. They are not touching. The lines are not touching. What does that mean? Well, if that happens, the final answer of this will be no solution, because they don't touch at all. Now, I hope you remember from our last chapter also that by looking at the equation, we can even tell that these lines are parallel because their slopes are 3 halves. So it's kind of cool to see all the connections that are being made with things we've learned before and the things that we are learning right now. And I want to just thank you for your patience, and I just hope that you had an awesome time understanding these concepts. And if you did not, please, please, please bring your questions to class. We're going to continue the rest of this in class. Give yourself a round of applause. Great job.